Day 638 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 561, array partition. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums of 2n integers, group these integers into n pairs where a1 and b1 or ab and a2 and b2 all the way up to an and bn, such that the sum of min ai and bi for all I is maximized. Return the maximized sum. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input nums equals an array of integers 1, 4, 3, 2. The output is 4. So what we want to do is we want to group these integers into pairs such that the sum of the min is maximized. So let's look at the explanation so we can see what that means. It says all possible pairings ignoring the ordering of elements are, we could group these 1 and 4 together. We could group this 2 and 3 together, right? So the min of 1, 4 would be 1. Boom. The min of 2 and 3 would be 2. Remember, the min is just, we want the minimum value of 2 and 3, which is 2. And here we want the minimum value of 1 and 4, which is 1. So then we do 1 plus 2, and that equals 3. Then another way we could group these elements together is we could group this 1 and 3 together and this 2 and 4 together, right? So when we do that, the min of 1 and 3 would be 1, and the min of 2 and 4 would be 2. Once again, 1 plus 2 is going to equal 3. Boom. So we're just adding the min of these pairings, right? So the min of this pair, once again, is 1. The min of this pair is 2. When we add them together, we get 3. We could also group this 1 and this 2 together. Remember, we already grouped this 1 and 4 together. We already grouped this 1 and 3 together. Now we're going to group this 1 and 2 together, right? Boom. Also, we already grouped this 4 and 2. We already grouped the 4 and 1 together. We already grouped the 4 and 2 together. So we're going to group 3 and 4 this time. Boom. So now we have 1 and 2 and 3 and 4. Now, once again, we want the min. So the smallest element out of 1 and 2 is 1. Boom. The smallest element, or we could look over here. The smallest element out of 1 and 2 is 1. The smallest element out of 3 and 4 is 3, right? So the min over here is 1. The min over here is 3, meaning the minimum value. 1 plus 3 is equal to 4. Boom. But it says we want to return the maximized sum, right? So in this case, the sum is 4. 4 is greater than 4. This 4 right here is greater than 3 and this 3, right? So since 4 is the maximized sum, meaning it's the largest sum out of all of the sums we were able to create, that's the maximum possible sum is 4. So we return 4. Boom. Now, just in case that didn't make sense, y'all, let's take a look at example 2. In example 2, our input nums equals an array of integers 6, 2, 6, 5, 1, and 2. This time the output is 1. It says the optimal pairing is 2, 1, 2, 5, 6, 6. So in this case, we have 3 pairs because we're grouping them into the n is 2n, right? So we're grouping them into pairs. So 2n would be 6. We're grouping them into n pairs. So we should have 6 elements here. Since we have 3 pairs, 2 times n is 6. That means we have 6 elements, right? So it should be the number of elements should be even. Boom. So once we group this into 3 pairs, it's telling us already we don't have to go through all of the pairs. It's telling us what the optimal grouping would be, right? So this right here is the optimal grouping that's going to get us the maximum sum. Then when we do the math on this pairing, right? So the minimum of 2 and 1 would be 1. The minimum of 2 and 5 would be 2, and the minimum of 6 and 6 would be 6. So 1 plus 2 plus 6 equals 9, and thus the output is 9. and we're just gonna take LeetCode's word for it. And I bet money if you you did any other groupings and you did this on your own and you tried different ways to group these pairs, then you would see that this is the largest maximum sum that will be able to be created. So now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult. So first thing we're going to do is we're going to sort the array in ascending order, and this is going to ensure that pairing adjacent elements are optimal. So we're just going to declare a variable called sorted num, and we're going to set that equal to nums dot sorted. Boom, put the parentheses. Boom. Then we need a variable to store the running sum of the chosen minimums. So we'll declare a variable called sum and set that equal to 0. Then we need to get the index for the first element in each pair. So we'll declare a variable called I, set that equal to 0. Boom. Then we need the index for the second element in each pair. So we'll declare another variable called J, and we can set that equal to 1. Boom. Now we need to iterate through the array in steps of 2. So we're going to say while J is less than sorted num dot count. Then we'll open up the brackets and we're going to add the smaller value of the current pair. Since the array is sorted, sorted num of I should be less than or equal to sorted num of J. So we're going to say sum plus equals min, open up the parentheses, sorted num square bracket I, come outside of that, comma, sorted num square bracket J. Boom. Then we're going to move to the next pair. We're going to increment I and J by 2 by coming underneath this. We're going to say I plus equals 2, and we're going to say J plus equals 2. Boom. Then we're going to return the maximum possible sum of the minimums by coming right here, and all we have to do is say return sum, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. Okay, we got ourselves a runtime error. Let's see where we went wrong. Oh, this should be plus equals 2, y'all, not equals 2. So now let's give it a run. See if that did the trick. Let's see, it's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Look at that, y'all. 75 milliseconds beats 6.25% of users. Now, we could definitely get those numbers up, but right now, I just want to do solutions that we can learn from, and we can be able to use the knowledge that we learned on future solutions. I feel like this is an easy solution to understand so that we can use what we learned later on in our LeetCode journey, because if you don't understand the solution, then you probably didn't learn anything, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.